Hello, beautiful people, and welcome. In today's video, we are going to go through some examples for solving exponential equations. In our class, we did talk about them being a level 1, a 2, 3, and a 4. Each level is increasing in complexity, a little bit more for you to do the higher the level is. So let's go ahead and start with a level 1. Now, with a level 1, what you're going to notice is all of the bases are going to be the same. So let's call this example 1. All of the bases are the same. So 3 to the power of negative 2x is equal to 3 to the power of 3 minus x. Now, with a level 1, you're going to notice, like I mentioned, the bases being the same. So I have a 3 and a 3 as a base. When that happens and you have the bases the same, at a level 1, so not a level 2, 3, or 4, you're going to remove the bases. You're going to bring down the exponents and set them equal to each other. So here we have a negative 2x is equal to 3 minus x. Now, after you do that, you're going to continue to solve for your x value. So for us, I am going to add an x to both sides. Use a calculator if you need to. Here's my dotted line. Here's a 3. I'm going to bring that down. Negative 2 and 1x plus 1 is a negative 1x. Be careful with that negative 1. I'm going to divide by negative 1, divide by negative 1. Again, use a calculator if you need to. Bring down your x. Is equal to 3 divided by negative 1 is a negative 3 for your answer. Now this would be a level 1. Let's go ahead and do another example. Example number 2. Here we have 4 to the power of negative 2v is equal to 64. And notice that our bases are not the same. So we have a 4 and we have a 64. So hopefully you can see that these are not the same number. So what you're going to do is you're going to pick up a calculator and you're going to try 4. Let me move that over. As a base. So you're going to do 4 caret 1. Now the reason we do 4 caret 1 is to double check that it gives you the correct number. We discussed that sometimes people do things to your calculator that will give you the wrong answer. So make sure this gives you the correct base. So 4 caret 1 should be 4. Now we're going to move up over to 4 caret 2. So 4 to the power of 2. Is that 64? No. We're going to check. 3. It is. So what that means is you have a level 2. You're going to bring down your 4 to the negative v power, but instead of writing your 64, I'm going to change 64 into what I have here on the calculator, 4 to the power of 3, or 4 cubed. Now I put that in parentheses just to show you that we are removing 64 and replacing it with 4 cubed, but you don't have to put parentheses here. Now, what do you notice? You notice that we have the bases that are the same. We have both with a base of 4. Now, since we have a base of 4, we are now at a level 1 type question where we can remove the bases, grab the exponents, and set them equal to each other. Negative 2v, this is 3, and we continue by dividing by negative 2. Here's my dotted line. Both sides. V is then equal to a negative 3 half. This is my answer. Moving on to the next one. Example number 3. For example number 3, we have 81 times 3 to the power of 3n is equal to 27. So here we notice that we have, again, not the same base. I have an 81, a 3, and a 27, not the same base. So what that means is I'm going to look for the smallest base. So my smallest base is 3. And I'm going to check, can 27 be created from a base of 3? And can 81 be created from a base of 3? So here's what we're going to do. We're going to check 3 caret 1, 3 to the power of 1. That does give us 3. So that's good. We're checking our calculator. Next, we're going to change that exponent of 1 into an exponent of 2. Does that give me 81? No. Does that give me 3? No. So we keep going. I do get a 27. So that is good. I'm going to do a little check mark there. That works. I'm not writing anything down besides that little check mark. And I am doing that in pencil just in case this does not work. And it does give me an 81. So now I'm going to pick up my pen and I'm going to open up what I am changing. So I am changing my 27 and I am changing my 81. Now, instead of writing a 27 and instead of writing an 81, we're going to change things. So 81 is now going to be 3 to the power of 4. 27, what did we say this was? Was 3 to the power of 3. So I'm going to change only the ones that needed to be replaced. If you don't need to replace it, don't write it differently. Keep it the same. So now we have, notice, all of our bases be the same. I got a 3, I got a 3, and I got a 3. So because all of our bases the same, do we drop the bases? No, actually we don't drop the bases here. This is a level 2 type question where there is something else for us to do before you drop the bases. And that step is you have to first combine before reaching a level 1. So this is not a level 1. You cannot drop the bases. When you have something like this, where you have the bases are the same, you are multiplying, you're going to rewrite this as 1 base of 3. Now what happens to the exponents? The exponents are going to be added. So I'm taking my exponent of 4, I'm taking my exponent of 3n, and I'm going to add them with 1 base of 3. Now on the other side, we're just dropping that down, no changes. There's only one thing here of 3 cubed. Okay, now that we're here, we are at a level 1. And because we are at a level 1, we can drop these 3's, bring down the exponents, set them equal to each other, and solve for n. So we have 4 plus 3n. 3 is here, and we continue. Dotted line, I'm going to subtract 4 both sides. We get 3 times n, positive 3. Make sure you look at the symbol. Here we got negative 4 and 3, which gives me a negative 1. Divide by 3, divide by 3 both sides, which gives us just n is equal to a negative 1/3 for your answer. Moving on to example number 4. We have 4n times 4 to the power of 2n is equal to 16. So 4 to the power of n times 4 to the power of 2n equals 16. So again, take a look at what we have. We have some bases that are the same, but we also have some things that are not the same, and that's this 16. So with bases that are the same, you can combine them here, just like we did in example number 3. So I can combine them. Now you could choose to wait to combine them, or you can combine them right away. Remember, if you have bases that have the same, let me take that back. When you have bases that are the same, you're going to add the exponents together. Bring down the 16 just to keep everything in line. take out your calculator, and once again, we're going to check, can we create 16 from a base of 4? So let's double check that that's 4, and it is. Then we're going to go 2. Oh, done. We can create 16, I'm just copying this on the left-hand side, from a base of 4. So that means I get 4 squared here. Again, what do we do once we reach to a level 1? A level 1, when the bases are the same, and there's only one base on each side, level 1, you're going to bring or carry the exponents down, set them equal to each other, so we get n plus 2n. Here's a 2. Be careful here when you're adding, subtracting. This is 1n and 2 n's. I'm being a little extra with my n pronunciation. So 1n plus 2 n's give us 3 n's. So there's nothing for me to add, subtract to the other side because we are counting how many n's we have. Here I have 3 times n, so this is where I can divide by 3. N is then equal to a positive 2/3. Okay, do a few more examples, and then we'll get you going on some classwork. Example number 5. We're going to start jumping into a little bit more challenging questions. We got 5, just kidding, example 5, and our numbers are 16a. Make your a little twirly so it doesn't look like a 9. We got 64 to the power of negative 3a plus 1. Again, make your a's a little twirly, otherwise you're going to assume it's a 9 and it's going to be wrong. First thing we want to notice is that we have two bases that are not the same. We got a 64 and we got a 16. So I'm going to take out my calculator and I'm going to say 16 caret 1. So 16 to the first power, double check and make sure that is 16, and that's good. Now my goal is to create 64. So can I create 64 from a base of 16? So here's 16. I double checked with an exponent of 1. Here's 2. And immediately this number is way too big. I needed to create 64 and I got 256. So can we create 64 from a base of 16? No. This means this is a level 4 question. So instead, you're going to try different bases. So your goal is to create common base. So you're going to try a base of, you can try 2, 3, 4, 5, 6, etc. Okay? So what you try is a guess and check method. It is your choice to try. If you want to try 4, great. If you want to try 3, also good. If you want to try 2, also good. But also you want to think about the numbers. 5 would probably not be a good base to try because 16 is not a multiple of 5 and neither is 64. So I'm going to just start with 2. It's the first one I wrote down, so I'm going to do 2 caret 1. Double check my calculator is working. Good. Now I'm going to do 2 to the power of 2. Not what I need. Still not what I need. 1 that I need, so I can create 16 from a base of 2, but can I create a 64? I don't know. So I'm going to keep going. That's not what I need. I can. Okay, so that's good news. I'm going to bring down, opening up parentheses, and here's an important thing for a level 4. When we have a level 4, you're going to take the outside exponents and you're going to place them on the outside of your parentheses. This is very, very, very important. You already had an exponent, so we have to keep the exponent that we already had. Then when you rewrite things, so I'm going to rewrite 64 first because I have that on my calculator. 2 to the power of 6 is 64. 2 to the power of 4 is 16. Then you're going to shift or migrate your parentheses. So this is very important. I will ask for your undivided attention here. You're going to bring down the 2. You're going to bring down the 4, still as an exponent. Then your parentheses shift around the exponent that was on the outside. So A was the original exponent. A is now in parentheses. Okay, let's go again. We're going to again bring down 2 to the power of 6. Then we're going to open up our parentheses and bring the original exponent of negative 3a plus 1 inside of those parentheses. They have to be in parentheses in this step. Next, notice that we have a level 1. I have an exponent of 4 times a. I have an exponent of 6 times negative 3 plus 1, but the bases are the same at 2. So level 1, we can remove those bases. I'm going to pick up all of my exponents. I'm going to bring those down. All of my exponents, bring those down. And now I have some solving to do. Notice that because we have 3a plus 1, which is a binomial, two things are inside of the parentheses, we're going to need to distribute the 6. 6 will go on to a negative 3. 6 will go on to a positive 1. On the left-hand side, there is nothing for us to distribute. We just have 4 times a, so we just have 4 times a. You can also say, if that bothers you, you can also just say 4a, which I'm going to use a whiteout to create just 4a, because we will need to combine certain things and that might mess us up. Seeing that little dot. I'm going to remove that dot. There we go. So we just have 4a. Then on the other side, we do have that distribution. So 3 times negative, let me take that back, 6 times negative 3, we get a negative 18a. 6 times 1, we get a positive 1, a positive 6. Now here, again, two-step equation, maybe 3 steps. Negative 6 minus 6, just kidding. Look, bring that whiteout back out. I'm not going to subtract 6. I wanted to, but we absolutely cannot. And the reason being is I already have an 4a here. If I subtract 6, it's going to kind of not do anything except just move 6 over. So I instead want to combine like terms. So when I move something, I want to be able to, or do I want to move that negative 6? No, it's okay. Let's go ahead instead subtract 18a. 18a will go away. Let's bring down the 6. And we got 4 minus 18 of negative 14 times a. Divide by negative 14. Divide by negative 14. Now, if you put a negative 6/14 as an answer, this will be marked wrong. This is not correct. The reason this is not correct is because you need to simplify your answers. You have a choice to make. You can do this by hand, or you can have the calculator do the work for you. So I'm going to choose to do the calculator. I like using the calculator when the number is smaller on top. 14 is bigger, it's on the bottom. In the denominator, 6 is on top. So I'm going to use a calculator. Ready? Negative 6 divided by 14. If I press enter, it will give me a decimal. Let's say it together. Decimals are not allowed. So, second, PRB, and that gives me a simplified answer of -3/7. Or you could have just divided by 2, top and bottom, getting your answer a little bit quicker. Right, moving on to example number 6. For example number 6, we have 125 to the power of 2x plus 3 is equal to 625. Again, notice that we have exponents. Do we have an exponent? Technically we have an exponent of 1, but I'm going to take that back and say instead of looking at the exponents, look at the bases. I think that's what I originally wanted to say. So we have a base of 125 and a base of 625. Again, those are not the same thing. I'm going to pick up a calculator and I'm going to check, can I create 625 from a base of 125? So we got 125, caret 1. Double check and make sure your calculator works. That's good. Go up, go over. Now we're going to do to the power of 2. Immediately, this is no. This number of 15,625 is too big. I needed 625. This is a lot bigger. So can we create 625 from a base of 125? No. So now we're going to say, okay, well, what can I create as a base that both of them could end up being rewritten, 125 and 625? This is where you can guess and check if you like, or there are some bases that are better than others. So since I have 125 and 625, I'm going to choose a base of 5. Double check your calculator is working. Good. I get 25. Nope, I don't need any of those. I get 125, which is good. I'm not writing anything down just in case this doesn't happen. And it does happen, so we're good. I'm going to rewrite this as 5 to the power of 4. And then I'm going to go back, and I'm going to rewrite 125 as 5 to the power of 3. Now, be careful, beware, alert. This is an original exponent. We have to write it on the outside of the parentheses. Okay? So then we migrate the parentheses. So 5 cubed stays. We're going to open up our parentheses and put in our original exponent inside the parentheses. This is very important. On the other side, we just have 5 to the 4th. There's nothing to do, so we can actually remove the parentheses. This is now a level 1. Drop the bases 5 on both sides, and we can continue. 3 times 2x plus 3 is equal to 4. Again, we need to distribute. 3 goes on to 2. 3 goes on to a positive 3. So we get 6x plus 9 is equal to 4. I'm going to subtract 9 both sides. Bring down the 6 times x. You guys can't see. Let me shift up just slightly. And we get 4 minus 9, which is a -5, divided by 6, divided by 6. Almost out of space, but x is equal to -5/6. This is your answer. All right, this is going to do one more example. And this example I wanted to do, actually, let's do 2 more. Let's do 2 more. Why not? 2 more. So example 7. And I'm going to just draw a line here, separating it out. For example 7, let's do something like 81p times 243 to the power of 2p minus 2 is equal to 9. Again, notice that we have different bases. I got an 81, I got a 243, and I got a 9. So different things. Find the smallest number. Here's 9 for our base, the smallest number in a base. And then we're going to take out our calculator and check. Can I create 81 from 9? Can I create 243 from 9? So let's check. So 9 caret 1. Yep, that works. So let's go ahead and do 2. So 81 can be created from a base of 9. But 243 cannot be created from a base of 9. It immediately goes to 729, which is too big. So although a base of 9 worked for 81, it did not work for 243. That means I have to try a different base. Again, you can guess and check 2, 3, 4, 5, 6 as a base, or can think about it a little bit and see which base do you think is going to be the best guess. For me, the best guess is 3. 3 caret 1. Okay, that works. So 3 squared, I get a 9. Good. Nope. Good. I get an 81. So 9 and 81 are good. We just need the 243. Oh, there it is. So I was able to get 9, 243, and 81 from a base of 3. So that means I'm going to open up parentheses, copy down our original exponents, and then 3 to the 5th power was 243. 3 to the power of 4 to the 4th power was 81. And then 3 squared was 9. Again, we do have original exponents. We had a p here and 2p minus 2. So when we copy this down for our next step, we're going to copy down the 3 to the power of 4, and then next to it, open up parentheses and put our original exponent there. 3 to the 5th power, open up parentheses, and put our original 2p minus 2 inside of the parentheses. So p is here, 2p minus 2 is here, and this is inside parentheses. Very important, you put them inside parentheses. Okay, so can we drop the bases here? No. This is not a level 1, this is a level 2. So you first will need to combine into one base before you can drop your bases. Now, when I say combine, you kind of just need to write them next to each other. Because we have the same base with multiplication, we're just going to combine by adding. And we're not actually going to add, we're just going to write the plus symbol, and then that way we can remove our exponent. Sorry, that way we can remove our bases and bring down our exponents. So 4 open p plus 5 open 2p minus 2. So notice that I'm technically adding, but I didn't actually do any addition. I just wrote them next to each other. Now that we have a level 1, we can eliminate, remove our bases of 3, and then continue solving. So we have 4p, don't forget your parentheses. And then we have 2 as a base. These are our bases. Okay, dotted line. There's a few things that we have to do in this example. Let's go ahead and deal with the parentheses and the distribution. 5 positive will go on to 2. 5 positive will go on to the negative. This is just for p plus 5 times 2 is 10p. 5 times negative 2 is a negative 10. We have a 2 here. Combine like terms on the same side first, so don't add, subtract anything. Just put these p's together on the same side. So we have 10 and 4p. We have 14 p's. Bring down the negative 10 and the 2. Now you can add 10 to both sides. We got 14 times p is equal to 12. Shift this up slightly. Divide by 14. Divide by 14. So p is equal to 12 fourteenths. And again, I'm putting this in a thinking bubble. This is not your answer. You have to simplify. So again, 12 is smaller than 14, so I'm just going to use a calculator. I got 12, 14, second PRB, and we got 6/7 as our answer. Don't forget, you have to simplify if you can. Let's do one more example. Now, this example I wanted to do because technically it is a level 1, even though it looks slightly different than what we are used to. And the reason it is a level 1 is because we are expecting you to have your exponential properties memorized. So example number 8 will look like 4 to the power of negative 2k equal to 1. So if you look at your bases, 4 is not 1. I hope that's obvious to you that these are not the same things. But our goal is to create the same base. So we look at the smaller number, 1, double check. Then we say, can I create 1 as a base into a 4? So can I create 4 from a base of 1? So if you notice, if I change my number, so now I'm already 1 to the power of 4, 1 to the power of, 8, 1 to the power of 20, it will always be 1. 1 times 1 times 1 times 1 times 1, no matter how many times you do that, will be 1. So can I create 4 from a base of 1? No. So then that goes into a level 3 or a level 4 where you have to change both of them, but you kind of don't need to. And the trick, there's a trick to this. Any base, and I'll put that in parentheses, to the power of 0 is 1. This is your trick. If you have any base, it doesn't matter what that base is, 2, 3, 4, 5, 6. If your power, if your exponent is 0, you will always get a value of 1. So this level, this question is supposed to be a level 1 question because of this property. So we're going to keep our 4 to the negative 2k power, but instead of writing 1, I'm going to change it to 4 to the power of 0. Let's double check that. 4 to the power of 0 is 1. And now because we have the same base, we can drop those bases, remove them, solve for k. Divide by negative 2, k is equal to 0 divided by negative 2 is 0. So again, your trick is any base to the power of 0 is 1. So for example, we can rewrite things like 5 to the 0 power is 1, 6 to the 0 power is 1, 7 to the 0 power is 1. Again, it doesn't matter. 27 to the 0 power is 1. 243 to the power of 0 is 1. All of them will be 1. So if you see a 1, look at the base that you want, like 4, and just change it to the power of 0. All right, beautiful people, thank you so much for your time. You have classwork to start if you're in my class. Other than that, I will see you in the next video. Bye!